Hey guys, Mr. Riz to help you out with the last section in our 2.3 notes. So what we're going to do is look at the applications of the derivative. And this is going to be a kind of short video because I want to test to see if you guys know your skills. You can always check your answers on this applications worksheet online. But I'm going to just give you some hints to get you started here. So we have a sponge that it's absorbing some water, and its length and its width and its height is changing based on how many minutes it's soaking up the water. So each one's changing a little bit differently. Now, if we want to find the volume of the sponge after 4 minutes, if we remember, volume is just simply the length times the width times the height. So if we look here, we can have a volume formula, which would just be the length, which is t plus 3, times the height, which or width, which is 1/2 t plus 2, and then the height, which is 1/4 t plus 1/2. Okay, so if you want to find the volume after 4 minutes, plug 4 into t, figure out what that is. So that's like 7 plus 4 plus 1.5, and get an answer there. And same thing if you want to find the volume after 8, plug those in. Now, to find the rate of change of the volume, you just need to find the derivative of the volume formula. So if we have this whole volume formula here, we just take the derivative of it. So there's actually two different ways to take the derivative here. We could do the product rule, which would be the derivative of this term, leave the 2 alone, plus leave this one alone, take the derivative of the middle term, leave the last one alone, and then plus take the derivative, or leave the first 2 alone, take the derivative of the end. So you take a derivative of all ports and add all 3 of those terms together. Or if we actually look at this, since this is not like sine or cosine or any trig or anything involved here, we could just distribute this to one polynomial for the volume formula. And then once we have a single polynomial, just do the power rule to find the derivative. I think that one might be a little bit easier and less of a mess at the end. Okay, now once we have that, you'll find the rate of change of the volume in 4 and 8 minutes. So you get your answer here for the derivative, plug in 4 and 8. Now, the rate of change for the surface area. So the surface area formula you might need to look at and remember that the surface area of any time is twice the length times the width plus twice the length times the height plus twice the width times the height. So what we would have to do here is go back to our formulas up at the top and plug in the length and the width part, plug in the length and the height part, and plug in the width and the height. So you can find that and just plug that in, you get your equation there. Then to find the rate of change of that, well, you'll just take whatever answer you get for this one, take the derivative of it, and plug in 4 and 8. If you guys need any room on this, feel free to do your work on a separate sheet of paper too, especially if you like write fairly large. Okay, the next part here, we got a boat going towards a dock. So if the distance measured in meters from the dock is that equation, t seconds after the engine. So we got a boat coming in, it turned off its engine and it's going to the dock. Hopefully it's slowing down, but it's getting towards the dock. If we want to find out how far the boat is away initially, that would be when the time is 0 seconds. So all we need to do is plug in 0 for t. Let's see, we'd get 10 times 6 over 3, 60 over 3. So what's that, 20 meters away? At what time will the boat hit the dock? Well, this problem here, we need to set the equation equal to 0 to hit the dock, because that means the distance would be 0. So we can kind of cross off this. You just want to figure out when will this top part equal 0. Sure, we can figure out what that number is. Probably rhymes with 6. Actually, no, 6 does not rhyme with 6, but I'm sure you guys can figure it out. All right, find the equation to find the velocity of the boat at any time. Well, if distance is the formula, the rate of change of distance is the velocity. So what we need to do here for this problem is find d prime of t. And there's no way to go around this. You will have to do the quotient rule. The only thing I might change is make this a 60 minus 10t over 3 plus t. That might be a little bit easier, a little bit less messy, and a little bit, you won't have as many sets of parentheses. The initial velocity of the boat would be, okay, once we have the derivative, you're going to plug in 0 to that equation. And it should be a negative answer because the distance is getting smaller. And what will be the velocity of the boat when it hits the dock? Well, hopefully it's super small, like nothing. but it's still got to hit the dot. So it will have a negative velocity. All you need to do is, once you know the time that you get for this answer up here, you're going to plug that number into the velocity equation. So there you go, guys. There's a couple hints to help you out with this. If you guys have any questions, let me know and reach out. But if not, good luck on this. And then we're going to start reviewing because we got a test over 2.3 coming up next. You guys have a great day. I will see you next time.